Hello friends, I welcome you all in this session. As you are aware, in previous session we were discussing about Six Sigma DMAC approach, and we have seen couple of Six Sigma tools, right? Let us look at some other tools. There is an important tool, it's called check sheet. Check sheet is basically a tool to collect data, and it's very simple tool. So let's say if you want to find out billing error has happened because of wrong amount, right? So on Monday how many errors have happened, right? So 1, 2, 3, 4, 5 and 3. So this is nothing but a tally chart, right? Similarly, operator errors can be due to again 3 and here again 7, right? So this is how you can collect data. So if you are in an organization having, let's say, 5 assembly lines, let's say there is one assembly line, and in that line there are 5 machines. So you can go to each machine and collect how many defective parts are there. So machine 1, machine 2, machine 5, right? And you can just collect defective parts on those machines, right? So this is a very simple tool, it's called check sheet, used for data collection, right? Of course, histogram, all of you would be knowing. Histogram is basically a tool to identify the frequency of quality defect occurrence and display quality performance. So this is quite a simple tool, histogram. Let's say I will give you an example. Let's say you are producing 100 parts per hour, right? And you want the height of the part should be 5 inches, right? And in 1 hour, as I said, you are producing 100 parts, right? Now for some of the parts the height is 95 centimeter, and for some of the parts it is 105 centimeters. So 100 plus minus 5 is the tolerance, right? Now you want to know how many parts are in one particular range. So first of all you should do what? You should count how many parts have got height equal to 95, how many parts have got height 96, and so on, right? And then you just come up with a class interval, right? Let's say class interval can be you can have 5 class intervals, or you can have 15 class intervals, or any number between these two, right? So once you have got class intervals, you should know, you can count actually what is the frequency in each class interval. So histogram is nothing but it's basically a data representation technique. When we have got large amount of data, we first of all prepare different classes, and then each class we count the frequencies, right? So this is quite an important tool as far as quality is concerned, right? Yeah, this is again an important tool, cause and effect diagram. It's also called fishbone diagram because it looks like fishbone, right? So you have got a problem, or you have got a defect in an assembly line. Now you need to analyze what are the reasons for that particular defect. The defect could be due to, as I said, multiple reasons. Many times you don't know why defect has occurred even after doing analysis, isn't it? So you need to reanalyze the causes of that particular defect. So this is your cause, this is your effect, this circle, this is your problem, right? Now this problem could be due to main improper training given to the worker. He is let's say he has overworked, and because of overworked employee, he is making mistakes. So, there could be again several reasons of this particular problem. Material, you may have faulty material, right. So, this could be another reason. Machine, method, environment. So, when you say machine is a problem, right, and because of that machine you are getting defective parts. Now, machine has got, again you can come up with different reasons. What are the problems in machine? Is there a problem of speed or its feed or depth of cut or vibration or some other reason, right. So, each of these reasons should be explored in detail, then only you will come to know the cause of the problem. So, this is quite an interesting chart as far as quality is concerned, right. Fishbone diagram or CE diagram, right, cause and effect diagram. Now, another tool is control chart. We have already seen run chart, right, and this is control chart. So, what is the difference between these two? Just think for a while. What is the difference between control chart and run chart? The basic difference is, in control chart you have got control limits. So, you have got upper control limit and you have got lower control limit. So, when you collect data over a period of time, you will come to know that which particular at which particular point the process is out of control. Let us say if this part, if this data had been here, then we would have said process is out of control, isn't it? So, this is control chart. You will have control limits, right. Of course, can be used to monitor ongoing production process quality and quality conformance to standards of quality, right. Then you have got some other Six Sigma tools. The first one is opportunity flow diagram. We have already seen flow diagram, right. So, opportunity flow diagram is basically a diagram which will tell you in a process what are different value adding activities and what are different non value adding activities. So, you will come to know where is the opportunity to make improvement. Since you know what are non value adding activities, you can improve them, right. So, that is why it is called opportunity flow diagram. Then you have got failure mode and effect analysis, FMEA. Failure mode and effect analysis is quite an important tool. In fact, this can be done before failure occurs. In fact, this should be done before failure occurs. So, first of all, you should in failure mode effect analysis, you should know what are the possible failures, right, and what is the probability of occurrence of those failures, how severe those failures are, isn't it, and then on the basis of all those things we will calculate something called risk priority number. In fact, in next slide it is there. So, you should calculate risk priority number for every potential cause of failure, right. Then you have got design of experiment. In fact, this is quite a broad area, design of experiment. In fact, we have seen in previous session that the value of y gets affected because of several controllable variables and because of several uncontrollable variables. So, setting those variables to improve value of y is nothing but design of experiment. So, how you are setting your input variables in a process to get desired output is nothing but design of experiment. So, if you look at this control chart and design of experiment, control chart, as I said, will tell you at which particular product is faulty product, or at which particular time your machine is producing faulty product, and then you take corrective action using cause and effect diagram. But if you look at design of experiment, it is basically a proactive approach. Cause and effect diagram is reactive approach. So, fault has occurred and then you are analyzing causes. That should not be done actually, isn't it? So, you should try to make your processes in such a way that you do not produce defective parts, and that can be done through design of experiments. So, before actually producing a product on a machine, you can perform some experiments, that if my input is changed from, let us say, -1 to +1, or let us say if speed of a machine is increased from 200 rpm to 500 rpm, what will happen to surface quality, isn't it? So, you can have different input variables, those input variables will have different settings, right. So, you can have 2 levels setting or 3 levels or 4 levels, right. So, you can perform several experiments, and there are some methods available for using those methods. You can effectively and efficiently perform these experiments. So, there is something called 2K fraction design, 2K -1 fraction design, and so on, right. You have a Taguchi method of design of experiment. So, design of experiment is the tool to get right quality product these days, right. So, this is DOE. Let us look at couple of charts which can be used in different phases of DMAC approach. So, as I said, DMAC, D stands for define, right. We will define the problem. So, this is basically a flow chart. So, you can use flow charts in define stage. It is not necessary that you can use flow chart in define stage only, you can use in other stages as well, right. So, if you look at this flow chart of a process, let us say you are doing photocopy of an original document, right. So, the process is put original on glass, close lid, adjust setting, right, what kind of contrast you want, what kind of, let us say, size you want, whether you want 200% size or 50% of the original document, right. Press start and remove original and copies, right. So, this is a process. Now, this process can be converted into CPOC diagram. It is called CPOC chart, right. CPOC stands for suppliers, input, process and output and customers, right. So, this is CPOC, SIPOC. So, it will tell you which are value adding activities and which are non value adding activity. Actually, CPOC diagram will give you a bird's eye view of the process. You can see what is happening in the process. So, let us say what are the who are the suppliers in this entire process of photocopying. So, you have got a manufacturer, you have got office supply company, you yourself because you are doing photocopy, power company, inputs are photocopier, right, paper. So, office supply is nothing but paper, right. Then you have got toner, toner is also a kind of office supply, right. Yourself, you are keeping original document, right. Then electricity, and the process is what, it's you are making photocopy, right. Output is what, a photocopy, right, or you can have multiple copies, right. So, this is your output. Customers are you yourself. If you want to keep a file of that, if you want to keep a copy of that document in your office file, so that would be also a customer. If you want to send it to others, then they are also customers, right. So, this is a process in which you can know CPOC diagram, right. So, supplier, input, process, output and customer, right. So, this is define phase. If you look at measure phase, then these are couple of charts you can use. So, you can use run chart. As I said, you want to measure something, right. In measure phase there should be some numbers. So, this is run chart, right. This is Pareto chart. I have already talked about Pareto chart, and this is nothing but data sheet, right, for collecting data, right. So, these are some of the charts which you can use in measure phase of Six Sigma, right. Then you have got, we have already discussed this. In analyze phase, what you do? You analyze what are the reasons for problem, isn't it? So, this is nothing but cause and effect diagram. So, let us say late pizza delivers on Friday and Saturdays. Now, you are trying to find out what are the reasons for late pizza deliveries, right. So, let us say people. So, people do not show up. So, that is why you are not able to deliver pizza in time. Let us say material. So, you have run out of ingredients. So, because of that you could not supply pizza in time, right. Similarly, machine and method. So, you can have not only these 4 reasons, you can have some more reasons added to this particular diagram. So, this analyze phase. The next phase is what? What is the next phase? I, right, improve, right, improve. So, let us look at which type of diagram you can use in improve phase. So, there is something called opportunity flow diagram. As I said, in opportunity flow diagram you will come to know which are value adding activities and which are not value adding activities. So, we will take the same process of photocopying of an original document, right. So, let us say what are different value adding activities. So, you are taking original document, then place original on photocopy machine, select size, select orientation, select how many numbers you want, right. So, these all are value added processes, right. Now, what are non value adding activities? Is copier in use? If it is in use, you will have to wait. So, waiting is a non value adding activity. If glass is dirty, then you need to clean it, right, that is a non value adding activity. Is paper available? If no, then you need to arrange papers, isn't it. So, the using opportunity flow diagram you can find out what are different value adding activities and non value adding. So, just focus on these non value adding activities and try to improve these activities, right. What was the final stage of DMAC process? It's control, right. So, you can use control chart. So, this is how you can use different types of charts in different phases, right. And as I said, it is not necessary that you should use one particular type of chart in one particular phase. You can use a chart in different phases also, right. Six Sigma is basically a process in which, as I said, you have got your responsibility is to reduce variability, and whenever you take Six Sigma project, it has got certain objectives. The major objective is to reduce variability. Sometimes you take Six Sigma project to reduce cost of a process, right. So, you can have different objectives for a Six Sigma team, and in Six Sigma team you can have 5 to 6 members. So, so you can have different Six Sigma teams working on different projects, and in a team you will have different team members. So, there would be a team leader and there would be some other members, right. So, the objective of Six Sigma is to attack on defects. So, that is why the designations or the titles given to team members are related to it is called karate, right. So, in karate you have got different in karate you just oppose your opponent, right, you attack on your opponent. So, here in Six Sigma also the team affects on what? defects, right. So, the objective of team is to attack on defects. So, the terminologies have been taken from that particular game, it's judo karate. So, you have got black belt, right. So, you can have black belt, you can have master black belt, you can have green belt, right, and you can have some more designations, right. So, there are different roles and responsibilities. So, executive leaders must champion the process of improvement. So, first of all, the organization will have to decide whether they want to go for Six Sigma or not. So, at the end of the day, it is the top boss, right, executives, and they will have to decide whether this process is to be adopted or not, right. So, the CEOs would be the champion of the process, right. Then you have got black belt, right, a person who coach or leads Six Sigma improvement team, right, would be a black belt. Now, then you can have master black belt who receives in depth training on statistical tools, statistical methods. So, he knows what is mean, he knows how to collect data, how to find out standard deviation, he knows how to find out let us say relationship between number of hours an employee working and defects he is producing. So, he will have to look at, let us say analysis like regression analysis, right. So, master black belt has got some knowledge about statistical tools, right. Then you can have green belt who has got enough Six Sigma training to participate in a team or in some companies to work individually on a small scale project, right. So, these are other roles and responsibilities in a Six Sigma. Let us look at some more tools for Six Sigma. There is something called Shingo system, or it is also known as fail safe mode. Fail safe mode. You should design your product in such a way that it should not fail. So, your design is basically safety against failure, right. So, you should design in such a way that it should not fail, right. And Shingo came up with several important points. He said that SQC methods do not prevent defects. In fact, he said that it is the employees who make mistakes or who are responsible for defects. Defects can be prevented by providing workers with feedback on errors. So, he focused on training and retraining of employees. He also focused on something called single minute exchange of dies. In fact, what happens in an assembly line, you have got different machines and you have got different jigs, fixtures, you have got different dies also. So, let us say in a press machine you have got different capacity of press in an assembly line of, let us say, an automobile company. So, you are producing components using a particular press, and let us say if you want to use some other component, if you want to make some other component, then you need to change the dies, right. So, the point he is trying to make is that you should reduce the setup time of changing dies, isn't it. You should change your jigs, fixtures and other cutting tools in as much small time as possible. Single minute of exchange does not mean just 1 minute, right. He is not saying that you should take 1 minute. The objective is to reduce the setup time as much as possible, right. So, Shingo's argument very important. And now there is something called Pokayoke. Pokayoke is another quality control tool. It is basically a safety against anything doing wrong. For example, whenever you go to an ATM, if you insert your card improperly, then you get a signal on the machine. Many times you know, the card comes out. So that is a process of making process foolproof, a mistake proof process. So Poka-yoke is quite an important tool for quality management. Let us look at some of the other points related to Shingo system. So before going for this, let me summarize, or let us proceed with this particular slide. So as I said, the reasons for defects are because of employees, right, and due to some other reasons as well, right. So the reasons could be, let us say, omitted processing errors, maybe due to wrong parts, error could be due to tools and jigs improperly prepared, isn't it. So we need to find out what is the connection between mistakes people make and the defects. If you are able to do this, then you are done. So you should know, you should find out, you should come up with a correlation between what kind of mistake has been done and what is the defect. If that chart is ready, then you can remove those mistakes. So a kind of chart like this can be prepared. So let us say we are saying that the errors are occurring due to human beings, right. So the errors could be due to intentional error, right, or misunderstanding. The worker did not understand instructions properly, right. So misunderstanding, forgetful, he forgets things, right, misidentification, right, willful, right, slowness, because operator is very slow, there would be defect, right, non supervision and surprise. Sometimes mistakes occur in spite of having all the things in place, right. So it is because of surprise you may make mistakes, right, and these are possible, you know, defects. Let us say omitted processing, adjusting error, improper tools and jigs. So in previous slide itself we have you know, listed all these defects, right. So a chart like this can be prepared, and we can say that whether the misunderstanding is the reason for omitted processing defect, this was the cause, right. So you can come up with strongly connected and connected circles, right. So let us say look at this, right. So because of slowness, this is the cause, right. So this kind of chart can be prepared, and once you are done with this kind of chart, you can know what are the reasons for failures. So with this, let me stop here. We will have next session, we will discuss something more about quality, and we will take up a new project management knowledge area. So thank you very much.